I think we're connected now. Going down there. That made a whole lot of sense. What's going on? Dream fam, how you doing this week? I'm gonna adjust the volume here on my headphones. Cool. Welcome back. Another week. It's more Haskell hacking. Well, let's get some. I think last week we were working on some stuff with the adventure engine. Locks, game locks, replacing locks, handling different locks. Some other stuff I thought about adding this week to our to-do list of things is a way to keep score. So we have to know when to reach the end of the game. Scoring rewards. Finishing the game. If I could type, that would be great. Okay. Super. Yeah, so we need like a reward system or something like that in order to, to be able to do stuff. Cool beans. So let's get to locks. Where were we with locks? I got the engine. So previously we had exit locks. We're just working on containers right now. We're trying to get the fire to go, and we're using like kind of a, not a literal lock, but the fire is a kind of lock for a container. That's what we're modeling in the world right now. And I believe we got it just kind of going so it's locked. If we look in the roaring fire. Yeah, so that's the locked text. It hurts your eyes, get too close. But there's something dark in there. If only you could put blah, blah, blah. We also have to fix the wrapping on that. Word wrapping on world messages. Call that one a bug. No, this is called a bug. No, for some reason it doesn't want to take the tag there. Bug. Whatever. There. Meh. Okay, so we have locked state right now when you try to look into the thing. So I guess the next thing is we should be able to unlock it if we have the right items to do that with. All right, so let's look at our model of the world right now. There's the fire with the fire lock. It's currently locked. I believe the second parameter is the entity ID of the key items we need to handle the unlock. But I'm just going to manually flip this around to unlocked. And just to make sure that when we actually do the unlocking that we can actually get the right text message there, and that should work. It's just recompiling. There we go. Okay. So if we look in the fire now, oh, we get undefined. So, right. That's because we get to that branch there. So when we do have a lock, when we go to use the look in container verb, the use of look for looking into containers, we have to handle that branch. So if the lock state is not locked, we can look into lock. Now we might want to be explicit with the code here and say like lock state lock is equal to unlocked. And then otherwise something else like Space Wizard. And I guess that's kind of the consequence of using guards here, in which case we might want to maybe put this in a case statement instead of a guard. I don't like having the extra branch there if we don't really need it. So that's what I'm going to do. Do that, move this down here, move it to a case of locked. Do. And turn that, and then unlocked. All right, we get the lock message again. Is it kind of the same here as well? I wonder. No, we're going to look in the other dictionary, so it's a little bit different. Lock key success messages? I don't know if we have that. I forget. Let's just pretend that's a thing for a moment, and we'll add this here to the world log messages. Did I type that wrong? I guess I did. Which is S, plural. Yes, that's what I meant. Okay, I don't think we have success messages by the look of it. Yeah, we just have messages for the errors. Because we need to give the user some kind of indication that when they successfully unlock it, that something good happened, right? So we should have some kind of message for that. I think we should just add that. All right, and then let's see. our fire lock. It's getting a bit wordy in here. That's okay. From list. The verb look that we're going to use. Although that's not going to be quite what we want when we actually look in there, but just maybe when we do the right action. Now that I think about it, so look in. So when it's unlocked, we should probably just do the normal behavior here. So I'm gonna put that in a where clause, I guess, so I can reuse it. There. And yeah, I think we should do the same thing for unlocked. Let's see, Cont. Cont is not in scope because I guess that has to be passed in. Well, that probably works. We found a redundant do here. Fair. Okay. Let's try that out. Once it's done compiling, bing, bing. Bada bing. We look in the container, in the fire. In the fire, you see, okay. So there's nothing technically in it because we didn't put anything in there, but then that would list out the items as you normally would, which is pretty much what we want. Okay, so now we just need to add the ability to lock and unlock this thing, in which case we need a verb to do that. All right. Now, here's the kind of the not so great thing that I don't like about this game engine so far. But it's okay. It's just not, yeah. So we're going with this idea of verbs doing most of the work for the player, and the player interacts through the world by using verbs and using them kind of in the present imperative sense, right? Like walk here, pick up this, open that, and they're kind of telling their player avatar to do those things, right? And the player avatar simulates doing them in the game world, and that's kind of how they interact. All right, and so in response to doing those things, if it was successful, we say, and update the scene, how the world changed in response to that action, that the avatar moving around and doing that thing. But here's a tricky thing. The author of this game world can only use verbs that are predefined by the engine. All right, so I have to predefine the verbs. I just wasn't able to think of a way that we could serialize them out in so that the game author could like write their own verbs for the game engine, right? Which is kind of limiting, because now it means that the author, i.e. myself, is going to have to, like, the content's going to be fairly limited. And if I want a new kind of verb to be added to the game, I have to kind of tie it with, I have to program it in, and then I have to like attach it to the items that the verb goes with. Or give it to the player, so on and so forth. So that's kind of the tricky thing. Now, there might be a way around this, maybe. I was just thinking, we have this idea of the verb alias map. And originally, the aliases were... alias map was a way for us to provide short names for the different verbs. I'm wondering if we hard code an unlock verb. Right, but in the alias map, right, we give it an alias that makes more sense, like ludonarratively, meaning like within the context of the game world. So in our fire example, we want to like pour water on the fire in order to put it out, or we give sand or something, some kind of item that has the verb to pour onto it. And we don't necessarily want to hard code pour, if we can help it. We did for like dig, for example, look and walk and all those sorts of things, kind of like basic ones. But maybe what we could do instead is have like a verb pour, and this can go to verb unlock. Right? And then we can give the verb pour to an item, and it'll be an alias for unlock. But this might backfire on us, because if we use a generic unlock to lock any lock, and you have another item that also points to unlock, another verb, sorry, that points to unlock, then you would technically be able to unlock with that verb, even though it narratively doesn't make sense. All right, so I'm leaning towards just implementing pour. Directly. Because I think that's probably like the only way we can get around this without implementing like some kind of language and having an interpreter and all this stuff. Which I'm not sure I want to get into with this game engine. But the drawback, the trade-off there, though, of course, is that implementing like a verb like pour, right now I'm just experimenting with the design of the engine itself and the different things you can do in the game engine, but I haven't like designed the content yet, so I don't know if I'm going to be using a verb pour in my game right now. However, we might have something like unlock. So I'm just going to kind of implement, I guess I'll implement it as unlock. So I'll go and we'll unlock the fire. I think it's probably the way to go. Okay, so we'll add the verb there to the default alias map. And that means now the game will do it, but it doesn't know how to handle that verb. We don't have a handler for it yet, so we should probably implement that. The way we do those is, yeah, we have like dig, take, so on and so forth, examine. And I'll put handle unlock. They all kind of have the same-ish type. Some optional args happening in our hard-coded kind of except T here. Concrete. Our concrete monad transformer. Okay, not unlock, unlock. Undefined. Okay, I gotta get back on home road here. I'm leaning. All right, undefined, handle unlock, and is there anywhere else? I think that's it. I think, unless, no, there's like handle verb up here, yeah. Where we pattern match on the verb given dispatching here, so unlock. We can do something with that. Give it the world, the args, and off to the races. Okay. Ooh, actually, I should probably checkpoint some stuff here. I want to just pull that hunk out and stash everything else. I don't know again. Okay. We are going to just back out of this quickly because it's not too bad to add. I just want to add a commit for the unlock state, the container. That's what we want to keep. Yep, want to keep that. Nope. Get rid of that. Just this. Yeah, so add unlock state view and container. We'll add look in container for unlocked state. That seems good. Like a good message. A useful one. A happy message. A lovely message. Okay. Back to the verb handling. We have some unlocking action. We have to add our handle section, handle unlock. And add it up here. Handle verb unlock. Okay. This ought to be pretty straightforward if we're just doing a generic kind of like unlock verb. It might get a little confusing. Might be a couple of tricks to it, but I think we'll be okay. I think we'll be fine. So when we handle the unlock, I'm imagining the command is just going to be like unlock thing. Now we also want to be able to do this with doors and with containers, which are two very different things in our model. So we'll have to figure out a way to search for those things and what the user meant. Or we can ask them to clarify by making a more parameter, like we load up the engine. We have the fire here. You could be like unlock fire. All right, that's undefined. All right, now so hit that branch. But what if we had the lock on the front door? Right, and we typed unlock fire. Right. You think, okay, well, it's not going to find a fire, an exit named front door, so it'll, if I type unlock fire, it's unambiguous. It means the fire, the game object in the room. But not necessarily, because the author might name an exit fire for some reason. So we have to disambiguate somehow, either by making a specific verb for unlocking containers as distinct from unlocking exits, or we have to request more clarifying information in the sentence, I suppose. Like unlock exit, front door, or unlock container, or unlock the fire. Something like that. Or we can like we can do, instead, like I was saying, like the verb, we can do unlock for containers, and we can do like open for doors. And that would disambiguate the two things. Even though they both have locks. It's tricky. Normally I would say, like, I want to say like unlock whatever. Hmm. What else could we do? Let's like unlock the fire. Thesaurus, help us. Unlock. Crack, free, Jimmy, liberate, pop, uncork. These all don't work very well. Open the door. How about open? Yeah. This is where we get tricky. The other thing we might be able to do, so like, let's go back to the fire idea. All right. What if we use an item on another item? So imagine I had like a water in my inventory. Use water on fire. Use key on front door. Pretty straightforward. Right, and that way we're using the thing on the other thing. I wonder if that's a way we could... I wonder if there's a way we could do that too, so that when we use it on the thing, there's a way that the author could define what happens when when you do that. That would be neat. And so we could have like unlock, right, as kind of like a generic thing that can happen to the object if it has a lock on it. So when you use thing in my inventory on object in the world, that kind of has a very specific meaning, right? That's pretty, that might work actually, yeah. I like that idea. Use key on door. Yeah, okay. I like that. I like that. I think I'm gonna try that. So let's back out of the lock thing then. Let's try use. Let's try use, yeah. Handle verb. Verb use. We'll dig thing, we'll put it down here. Handle use. Okay, this might be a little bit better. List of text is all we get. Says args and accept T. Game error. World. Okay. Okay. Let's take our world as a parameter. Now we have to parse the list of texts that we get. Our parser is pretty simple. Doesn't do anything super amazing with the input. All it does is just split things out by words, basically, with spaces. All right, so we get args here. It's up to us to kind of, in the handler, to like parse the rest of the args and figure out what the user meant. So that might look like this. We could... so it's going to use a thing name. What's going to be the first element of our list. So I'll make that a let binding. And of course, that's going to be a list, so that could potentially be empty. So we want a safer version of head. I don't know if I have a head may. That would be nice. All right. The second one should be on. So how would we... we could do like... yeah. I don't like that terribly much. It's going to get a little ugly. Get out lists. Yeah, we might want to have like a basic tokenizing parser or something to extract out this sentence. Yeah, because then, yeah, you know, basically, what could we do? We could split. Then we got two lists. We get pattern match-ish. Like a terrible way of parsing stuff. Which would not be the greatest, because if we tried to do that, well, let's imagine that we do it like this, like say, bap, and have it like this, where it's like the object name, the word on, and the I forget the grammatical names of them. They're supposed to be like the thing you're acting on. And then some other rest of the list, right? That would be this. And then we'd have to have like some other branch where we couldn't successfully pattern match this way. So I guess the simplest way we could test this is to turn the world with the world log messages. In the error case, and in this case, let's just add another world message with I don't know, some successful thing like use object name on acting on if I can figure out how. It's not in scope though, because what did I do? I gotta pull the messages out. So I'm gonna bind them up here. Messages equals world log messages of the world. If I could type, that would be great. Messages. Hooray! Okay. Yeah. And what's the problem with this, Haskell? Oh, right. It's not square brackets. It should be parentheses. That should compile. Yeah. Okay. So now we try this. If I wasn't too hot on the hop there, too quick. There we go. So if I use foo on bar, we should get. I don't know what you mean by use. Oops. It's not in the player's default verb map yet. Verb use. Maybe give it a short one. Okay. Looking good. Use foo on bar. Okay, that works. So I'll try to use foo on bar if I can figure out how. We also might want to be able to do like use foo, like just to generically use an item, not necessarily on another item. We can potentially handle that later. Okay. That's cool. Let's now let's think about what we can do next. What does it mean to use an object on another object? And what does it mean to react to that? Like, how do we represent that? Let's throw some ideas around. We have a data structure, of course. What is an object interaction? Or, yeah, object interaction, right? Maybe it's a record? I don't know, the grammatical structure, use X on bar. Oop, that's a morphology thing. I don't even know what the heck that is. The X-bar theory of phrase structure. Interesting. Noun, verb, adjective, determiner, preposition. So that's a whole bunch of maybe NLP type stuff. Specifier, maybe? Complement, adjunct, let's see, some grammatical structures. Okay, independent clause. Yeah. Independent clause is a subject and a predicate. Makes sense on its own. Predicate is part of the sentence that contains the verb. Along with the subject, the predicate helps create a complete thought. Okay. Not quite what I'm going for. But something like that. Subject, predicate. So the object, interaction, subject. Entity, ID of some game object. Object, interaction, predicate. Entity ID of another game object. And here's the thing, like, how do we model what it should do? Hmm. The patient, the library teacher, the adjective and noun. Boom. Well, we could just maybe add the verb. Now, what can we do with this? add show, we could interpret it in some way. How would we do this? Like, if we say eval object interaction. All right, I take one of these. What would it output? Well, we'd need a world too. A new state of the world, potentially. Potentially a game error. Something like that. Now, so in this interpretation of eval object interaction, we take a world, we take this data, and we're supposed to produce maybe a game, or maybe another state of the world. Well, what can we do with the entity ID? The game object, the two objects, the subject, the predicate, and the verb. Right, we'd have to define that entirely in here, what that does and what that means. Right, like this, at the term level, we would have to, everything in eval, object interaction, every interaction in the game, we would have to like put in here to figure out what it should do. Right, I think that's basically the only thing we could do in here. Right, otherwise we could have like another level of indirection, maybe? Like command verb or something like that. And in our case, like for unlocking locks, might be more. Driving EQ and show we need an instance for that, of course. Now, this would mean that we could give, we'd have to look up the entity IDs, right, in order to construct one of these. Give it a command, and then dispatch to some way of like getting those actual objects and passing them in. right? Which is what world would do, I guess, and object interaction here. So eval object interaction. Right, we could look up, we have a world here and our object interaction. We have the subject ID, the predicate ID, and the command verb. I'll change that to command. And the command. That's all we have available to us to do something. And well, let's see what we can, how far we can get. We can do, we can look up items out of the world. And we have an entity ID of a game object. Which isn't terribly useful. So we go to the definition of world. Well, we can really look up our, well, we can look up the game objects. Exits. All right, we wouldn't be able to, we can only do entity IDs of game objects in this object interaction. All right, so we might need a type for the other, that kind of encapsulates the other kind of interaction we can have with objects and exits. We could also look in the player inventory as well, because we have entity IDs of game objects there. That we could use. But that's it. So we can interact from objects from the inventory with other world objects and things like that. The provenance of those, so this is an entity ID into the game object. So this really points into the map here, the actual game object, get the actual game object. Yeah, so basically we're only really looking to world objects to actually get the game objects themselves. So let's put that, let's keep that up there. Let's go down to our eval. All right, so we can get the subject and predicate from there. I think we have some helper functions for that. Get object inventories or just get object period. That's the one we want. All right, so we can get the subject object with get object world subject ID. We can get the predicate object, one we're going to act on. Get object world predicate ID. And that's what we can do so far. So we've used subject ID and predicate ID. We now have to use command. We need a monad m context. That's fine. Pop, 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 pop. So we have those. And basically now we can go, we need some kind of function that takes the subject object, predicate object, and the command, and it has to return a new world. Apply to that appear like that, so it returns the new version of the world. That command is game object command, game object command world. Right. So we have unlock right now is the only thing we can work on that with that function. So we could what do we call that? Like I want to give that function a name. I'm just going to take its type from the whole. I'm just going to call it prob. All right, so now we got a valid fold fit for that. Put it there. Do command, do. Yeah, something like that, maybe. Rose by another name, but and then what could we do with object that command? So that's where we could, we'd have to pattern match on the command, I guess. So we'd have to like look at the objects we have. Subject. Red. And say unlock is the only one we can pattern match on right now. Boom. Let's get some said. Subj obj. Red obj. Now we just have to return a new world. A world. Okay. Well, now it's kind of clear what we can do, or what we're supposed to do anyway. Right? We have to figure out what these two objects are and kind of scrutinize them, see if we can actually do unlocking on them. Or unlock the predicate object using the subject object. All right, so we're going to... Well, this has to be a pure function, so that's not so bad. What are we going to do? Well, well, actually, what can we do? We got the lock type first. So we're going to need to know if the predicate object has a lock. Like the fire lock, for example. Right? The fire is a game object, a container, where we have this maybe just fire lock. Now, in this function down here, in do object command, the predicate object, we don't have a way to tell whether this game object has a lock or not. I know from Foresight, because I've defined containers to have these things that we could pull it apart and figure that out. Or we can get into like has style type classes, right, and provide an instance for it for our containers, for example. And that way, we could potentially reuse that class for exits if we want to put locks on those. And then we have like kind of a common interface for things that have locks. Let's kind of do it let's do it the pulling apart way first, and because if we don't end up using the type class very much anyway, it might not be so bad to have the extra code just to avoid having a generic type class we're only going to really use like for one or two things in this one case. So we might not get a whole lot of bang under the buck if we go down that route. Let's just see what it looks like without that first. Okay. So that means we have to pattern match on the predicate object. All right. Game object has two constructors, I believe. They should be, oh no, it's a record. So it's not a case yet. We have to get, well, we case on the game object. It's feeling very JavaScripty right now of the predicate object. And this is the thing, I think, that has the two cases. Yeah. There's that. It's object item or object container. So we know that object containers can have locks. So that's the only one we care about. The other one would be an error. Container. Okay, so we're in this branch now. If we have an object container, then we know that it has a lock if the container field has just a lock. Container. Yeah, the container lock is just. Nothing. We have an error case there as well. Just lock. Okay, now we have a lock in scope. In this branch. And now we can investigate the subject object. I think, oh wait, we did it by IDs, didn't we? We might have jumped the shark fetching that. Lock. The idea with the locks was that you'd have certain key items. Yeah, an entity ID for the item in there instead of thing. Yo. Okay, we might have to adjust a little bit here. There should be an entity ID for a game object, not an item. First off. Well, we do have the subject ID in place, which should be fine. We might not actually need the subject object in this case, but maybe for other commands we would. Potentially. But in this case, we can give, if the subject ID is in the lock key items, then we can unlock the lock. So we can replace that game object in the world map, modify it there so that its state is now unlocked, and that should do it. All right. So we can go like this. We can say if the subject ID is an element of lock key items of lock. All right, then we can do our super happy fun times here. Otherwise, forget about it. We'll do something else. Okay, in this case, we want to return the world where the world game objects, world objects, are equal to the world. We're going to do modify and modify. We're going to modify the world objects of world. We don't need that there. That's what we're going to do, probably. Let's see, couldn't match type unit. Okay, sorry. We're stacking up the errors here, the type errors. Yeah, so this one is, we're not quite using modify, right? M.modify is probably one, actually. Oh, it doesn't export modified. What is it? Data.map. Map. That's strict. Is it update? It might be update or adjust. Yeah, update, adjust is probably what we want, I think. Yeah, okay, let's go with adjust. Adjust. That takes the function to do the updating, the key. So we have to give the predicate ID that we're updating and the map. Looks like, yeah. Cool. So now we have a function game object to game object. That's going to be our predicate object, the lock. And we're going to update the lock, flip the lock. Or unlock. The lock, basically. Okay, that's what we're going to do. We have to define it still, but it's there. And let's just get rid of some of these typos. These are all error cases. Game errors for this case where you're just trying to do something that doesn't work. You don't have the right item. You can't do that on the subject. That kind of thing. We could do it. We can make a new one like invalid object command or invalid. What do we have? Object in room, not a inventory, does not exist. Missing command, unrecognized verb, missing parameter. More like invalid object. Invalid, what did we, invalid object interaction? We're going to give the text the name of the subject, the name of the object, of the predicate, and the command that was used. I think that'll be good. Let's jump back over to our hole and fill that in. So here we're going to, let's remove the pure from here. Make this an accept T game error M world. So I can throw error invalid object interaction. And this is unlock. Yes, okay, that's that. That's text. So we know this one should be the game object name of the subject object. Yeah, so we did end up using it. That's good. And the next one should be the game object name of the predicate object. I guess I'm not down in scope down here, so subobj, predobj. Yeah, we passed them in here. That's okay. Okay, those look happy. Once it catches up with us here. Sub j obj. Okay, cool. All right, we can't, so invalid object interaction, we can't unlock an object item because an object item doesn't have a lock on it, or at least they don't yet. But if we're looking at a container, we can. The container has no lock, and you try to unlock it. That's also an invalid object interaction, but it's already unlocked. So maybe there's like, it's not an invalid object interaction, it's just already unlocked. Or it has no lock. So that's more like an invalid use of a verb. Not unrecognized, missing command. Not a missing command, but not an unrecognized verb. It's a missing, inappropriate use. It doesn't, missing command. Invalid object, invalid use of verb. What else could we do? Not missing command, but like creative use of command. Valid command text. Yeah, let's just do invalid command. Why not? Let's not hamstring ourselves in our progress over the naming of this error. Let's just jump to it. Invalid command. Let's say the game object name of the predicate object predobj is not locked. In the case where we do have a lock, but we don't have the right item to unlock it, in that case, we should get the error message we want to display from the game object and add it to the world log messages. I don't know why the indentation is going crazy over here, but we'll do this, and I think we have some helpers for that. So, that's going to be a maybe when we look up the thing, so we're going to have to fix that, but let's do this first. Okay. So the unlock error is going to be the m.lookup of the... We're mapping it by verb name, aren't we? So we might have to change that. We should probably maybe map by the command. Or just straight up be an error, a text field actually, maybe on the thing. Yeah, maybe we don't need the maps to the verbs thing. So we could do like a game verb lock. Open unlock error. Message. So far, it doesn't need to be in a do block. Just be like that. Of the locks, we're going to have to bring that into scope. And we do this, where we don't change the state of the world. World log messages just gets updated. So world log messages of the world gets appended, combined with the unlock error. Okay, so let's update our definition of locks to remove the error messages map and the success messages map to just being a lock error message of text and a lock success message, or maybe not error message, fail message, success message of text. Hey, Graceful Potato, how you doing? Welcome back. Nice, thanks for dropping by and checking out the stream. Now we're working on an interactive fiction game. It doesn't run in the terminal though. We have a GUI front end here, based on the Monomer library, which uses, it's kind of like a, well, it uses the Elm architecture for your setting up, for interacting with its API and interacting with it. Under the hood, it's just using SDL and has like a cool pure Haskell widget type structure for structuring widgets and rendering stuff to that SDL canvas. So it's actually graphical. And there will be eventually some graphics to add to the game. But for now, we're just rendering out text. We're working on locking right now. So handling object interactions, using things on other things to lock and unlock them, or what have you. So sort of like a texternal game, but it's just a little bit extra. Have you ever played text adventure style games like Zork or some more modern ones, maybe? Often called interactive fiction games these days. Let's see, we can get rid of that. Our next type error is going to be down here. So it's going to be fail message. It's not messages, it's going to be message. Which means this no longer needs to be a lookup. Yeah. So let's be locked. Just lock fail message there. We might still need the pure just because we're in that world. Okay, that fixes that type error. Yeah, we know about that one. We're expecting that one or that one. So that one should be fail message. Don't need the parentheses there. Let's see. I think we still need a pure on you as well. Okay, then we just need to implement unlocked. Let's just see if we have any other type errors. Yes, a few more I'm expecting. 2, 4, 6. Well, my jump isn't working anymore there. Yeah, so we don't need this list anymore here. Well, it should just be a text. Same with this. Okay, and now we just have to implement that. Yeah. Okay, for some reason my jump to errors is no longer working, so I have to like do this manually. I don't know what I did. There, that will go away, huh? And we have to implement the unlock function. And that should do us for unlocking our good old friend, the lock. Now, unlock is a game object to game object. We know that this is a record with an object buried in it with 2 cases, which we have to match on again. It's not super fun. All right. Don't care about the name, don't care about the thing. It's a container item. We do care about that. I'll pull it in like this. And pull in O like that. All we care about are I think it's 4 fields and the final field. Oh, 3 fields. container lock. I don't like this already. I don't want to do this again. This code's nasty. So then we got to dive into the lock here. This is what we need to flip. The lock state. And I think that's fine. Yeah. And otherwise, we just leave it alone. We might be better off just doing it. We need a lens or something like that to get in there. Or we can pass in the lock. We have lock and scope. So then unlock becomes a type. Where do I got the parser now? This is probably what's tripping everything up. Is that not? Well, probably not, but if it's a parser. Where is it? Well, I'm already in a where block. Okay, that's what the problem is. Yes, silly me. Indentation. Sometimes it works, sometimes it doesn't. Okay. So that's what our type of our function should be. Let's put that type there instead of ints. And we should be good to go. Okay. And whatever the state is, we want a lock of the opposite of that. So we're gonna this is getting kind of nasty here. Yeah, because I'm going to do this anyway. Ah, man. Here we go. Yeah, this is not getting nice. So then we have container. Just whatever. No, we don't need the pull apart that. We just need this C itself, the container itself. But we need to know it's a container. I think it's just 3 fields. unlock. Otherwise, doesn't matter. We can ignore the arguments, except for the object. We just return that. We do object. Okay, so the object container, the C is here. That's what I need. Okay. There we go. Yes. Ugh. Okay. I think this is the kind of code where lenses become quite useful. Deeply nested hierarchies of records and structures. Okay, so here we just go, we want O with the game object equal to OC. No, we don't need that. The game object to be an object container of a C. I don't think we need the apply there, with the lock to be just L, where lock state is equal to the opposite of whatever state it's in. And normally with bool, I could just do a normal Boolean flip trick. We implemented this with kind of a more domain-specific type. So I can have like a flip lock state function of S, and that should do that. What is flip lock state? Find that below. Do some breathing room. And we'll figure out what that type is. Yeah. Lock state to lock state. All right, so if we have locked becomes unlocked. If it becomes unlocked, then we flip it to locked. Okay. Oh, a whole bunch of fun stuff. Okay, I got a little bit liberal in my use of some things here. This, I guess, is not necessary. Well, then that should be... I don't want a functor instance. Why do you think I need a functor instance? Oh, is it because I don't have a monad M on the type over here? Probably, yeah. That's why. Some sort of type class so I can define not? Probably. Like I might be able to... I don't know if I'd be able to use coerce. Because the constructors for bool and false might have different runtime representations than locked and unlocked. Even though they behave the same. Like semantically. Almost, but not quite. So flip. It's fine. I don't know if there's a type class for that though. So this one is gamer. Oh yes, yeah, that's me. This should be separated from that. Invalid object interaction. Oh, invalid command. No, sorry. What do we want here? That's a precedence fun time, the happy thing. Yeah, and I think that probably worked. Looks like it good. Well, at least it compiled. I think, hopefully we got the logic right. Let's go and update our test container so that we can try this out. And set it to locked initially. Now we don't have any key items yet in our state as well. Let's just pretend we can use, I don't know, the coin to put out the fire for now. Just to test it with. The coin entity ID is 9. So let's put that in here. Entity ID 9. Oh, we haven't, the other thing that's not going to make this work yet, we haven't hooked up this command to the code quite yet, to the use verb. So that's the next part actually we have to do. So, use. All right, so we just have a message that we display here. We actually need to use that function now, that object interaction type stuff, in order to do what we want to do. So now it's the responsibility of the handle use function to construct an object interaction and call that function to get a new version of the world that we can then return from handle use here and update the state of the world with. So now we have, when we do that, when we handle this command, all we have are the textual names that the user is input, and we kind of have to like search for this object somewhere. And it should be the player's inventory, right? If you're going to use something on something else, you should be holding it. So the acting on is the predicate. And now that we have that verb, we should update the verb image of that. Predicate name. And Ready, get on. Yeah, and then we should look that up in the world, the room objects, and then get those two IDs. That's all we need. Oh, and then we need to come up with the command too. Right, because we want to unlock the thing. So we need some way to link up that unlock command to this here, or for us to look up what command we should use from somewhere. That might give us a bit of an ability to actually let the author kind of somewhat pre-program, like some minor programming, just by defining data structures that we can serialize and load, and when we load the game engine to do here. Because we could serialize the command, and we can serialize the object names, the predicate names, or the entity IDs. And so if we looked up in that map for the command that should be used for this case, when we use the verb use, then we know what command we can, we would just get the command from that. Then we can call the eval command, or the eval object interaction with that object interaction. Yeah. That would be like, I'm thinking some kind of map-like thing. That would be like, the key would be, maybe it could be like a tuple or a triple. Or just some kind of data structure. I don't know what to call it, but like, just gonna float foo for a second, just so you can kind of see what I'm getting at. Maybe the name will become clear. But if we have like a verb here and an entity ID of a game object, entity ID of a game object, and a command. That's all it does, is it ties together these three bits of data in order to get us this piece here. All right. So this would be like the key. And then we would have a map that we can look up into a foo. Um, 9 with whatever the chest is. Say, I think it's like 12 or 13 or something. And that would give us the command. And then it would give us a command. It would map to a command. So like, when the verb use is used with these two parameters, entity ID 9 and entity ID 13, then you should use the command unlock, or try to use the command unlock. All right, so the user can compose these and then tell us through the map what command to use, and then we can construct the interaction and evaluate it and see what happens. But what to call foo? Command key? Something like that. Or just the... Yeah, this might be too specific with the entity IDs here, because different verbs take different number of parameters. Or... Or you just give us the command. No, because we don't know what the command is. We're looking up the command. Maybe we don't need the command. Maybe a verb is good enough. Let's go back to that eval object interaction thing. Maybe verb is fine here. What if we got rid of that? Would still mean the same thing. We did like this. Or use, sorry. It loses a bit of semantic meaning there. Right now, we just have unlock. Graceful potato, just unlock. We're just trying to get the usage of like interacting with game locking things. Unlocking things. And so the idea is that we would be able to fire up the game, type in, use, say, coin on fire. In this case, fires this object here, roaring fire. And then it would match down to our command handler for use, and then evaluate this interaction. The idea, though, is that we might have different contexts in which we use this sentence, where fire, in this case, is the fire, the roaring fire. I use this on room. But the other thing we were thinking about is like exits as well, which we might not be able to support this in this structure. So maybe we should ignore exits for now, but yeah, this is what we want. Use coin on fire. Well, he doesn't know how to do that yet, but just trying to hook that up. That's probably seems like it'll be okay. The only invalid command, valid object interaction. So that error message still takes the thing, but let's just try it. That looks like it's almost compiling except for that. Let's just fix that one and just see if this will kind of work roughly where the kind of what we want. Clean it up after. So handle use. Okay. So we know how to get the... I think we know how to get the game object names. The object ID from its name, but we need to figure out how to do that. The predicate ID, same thing. Then we get the new world state by evaluating. Now, I think I want to get rid of that record now because I just want to pass the parameters in directly. But we'll just work with this. Object interaction. The subject is the object ID. So it takes a world. Object ID, the predicate ID, and the action, or the verb, which we know in this case is going to be use. So just to fill in those holes, I think we have some helper functions for that. Yeah, get object in current room. So that's for the subject ID. Or the predicate name. Jump to the next one. There we go. Let's get the world and the predicate name. And now we just got to get the object ID. And that's from the player's inventory. Get object in inventory is the other function they'll do it by name. Doesn't look like it. Let's see, fetch. Hey, fetch. That just goes into the map lookup. Yeah. So it doesn't do any normalization on the text input. So for our arguments, if the user types in like weird caps and stuff, we should probably... I don't know if we should normalize those for the lookup, but I think that's how it works. So that's the function we need. Let's just use it like that. Object name. There. And I think that should hook it all up. Except we want to use world prime here. Probably want to use the success method from that object. However, let's just see if that worked. Gameplays wise, I think that should flip the lock around for us. So it should start off locked. So if we try to look in the fire, we get the fail message. All right, it hurts your eyes to look too close, but there's something dark in there. If only you could put blah blah. We gotta fix text wrapping. So ignore that for now. But if we pick up the shovel, all right, we dig, and we get a coin. So we have the weird coin in our inventory. We use coin on fire. So I have to use... So this is where our parser is going to get bad. Because we can't do a weird coin like this on fire. It won't pick up. Because we tokenize everything by the exact position in the thing, which is kind of... So how can I cheat? How can I cheat? We can make it the ID shovel for the shovel instead as the key to unlocking the fire. That's how we can cheat for now. So the shovel's ID is 1. Let's put out the fire with a shovel. So I look in the fire. Okay. I pick up the shovel. I'm like, okay, let's try that. Use shovel on fire. Okay. Now if I look in the fire. Still saying only good about the flames. That might only because we have no, that might not have flipped the state around. This might not have worked the way we expected it to. What's happening there? The entity ID of 1, that should be just fine. And we'll use so we're getting the right log message. Eval object interaction hopefully is returning the right world. Yes, we know that that's not a total function. Yeah, so that should adjust that object, change that game object around. That container, which is should be the fire container. Let us invoke our friend debug.trace. We're running a little over time today, but I just want to look at that quickly before we call it. See if we can get this to work. Okay. Let's import debug.trace quickly. And see if we can't see that the state is being updated properly with the flipped lock. So, I think we did verify that this look in container, when it's unlocked, does work. So, eval, object interaction. Yes, let us jump to where we use it. And before we return with pure, we'll just output the state of world prime. Okay, so we pick up the shovel. All right, we're going to use shovel on fire. So we do get to that part of the code. And this is the current state, current value of world prime before we return it. So that should be entity ID 10. Okay. The map of game objects. It's here. The shovel. Entity ID 1. So the fire should be down here. Coin. There we are. Fire, roaring fire. So its entity ID is 10 in this database, and it's roaring flame. Container locks, just lock. Key items, entity ID, and again, doing 1. SSS. So it does show unlocked. So it is getting updated properly, as we expected. Ah, okay, it is working. Maybe I just jumped the gun on starting up the game engine before it was done compiling. Okay, cool. So now the state's unlocked. We can look in it. Okay, cool. All right, well, that kind of works. That's kind of okay. But we're going to have to call it there. And clean this up next week. Fix it up and make it look good. See it and kind of review what we think of what I think of the design here and what we think of the design. If we like the way we're handling object interactions here, I think one of the things I want to clean up is probably that record, although I might leave it, this object interaction record. Only because if we put it in a record instead of making it actual function parameters to eval object interaction here, we can serialize them. Which could be nice for game authors when they want to like say, okay, when this entity object and this entity object are involved in an interaction and this verb is used, you know, they can interact. So the verb kind of defines what can be done between the two, and so they kind of have to be handled the same way. So I'm not sure how well that's going to exactly work. So we might get rid of it, but I'm kind of iffy on it right now. I need to explore it a little more. However, we did get the unlocking to work. So this is one way we can do it. I'm going to create a commit for it, I guess. Code's kind of dirty. Let's just fix up a couple of these messages. Let's get rid of those warnings. Get rid of that one. Probably wanted me to do something like this. To avoid the use of the $sign, maybe? Yeah. A redundant guard. Yeah, okay, no problem. We'll get rid of that. And do object command. Otherwise, for anything else, we could just return Invalid command. I don't know what to put in there for now, but we'll just put in something to satisfy type checker. That should be good there. Get rid of debug.trace. And then we need a nice error message for invalid object interaction and invalid command. Command like that, and we'll just actually I'm going to ignore command here. We're going to get rid of that. I don't know how to use subj on red. And invalid command. We'll just ignore the text message for now. I'll figure out what to do with it. Yeah. Pred is, oh, let's just change the S and P then. P. There we go. Okay. Super. Super duper. Let's see. That should be all those. Yeah, I know about those other ones. We'll leave those for now. Okay, we're good to compile now. Let's go. Object interaction to handle unlocking locks with items. Cool. Let's push those up, and there you go. So, if you're just joining us and following along, it's your first time, the code for this project lives here. Agent Ultra, that's the stream, that's me, and it's Adventure Engine. So we just push that up. Should be available. If you would like to chat with myself or other people interested in functional programming or other declarative style languages, check that link out above, declarative.tv. It's pretty great. Lots of awesome people there. There's a Discord server where we have a channel for this stream here, as well as for others. And you should totally check that out. Give me a follow, of course, on Twitch if you want notifications when I stream. I typically do these once a week on Tuesday evenings in the Eastern Standard Time Zone, at about 10 after 8 in the evening. But sometimes we have a little extra. I do like surprise streams and stuff. So otherwise, if you're watching on YouTube, you know what to do there. So do that if you like what you see. And as always, may your monads be free. May your types always check. Happy hacking out there. Take it easy.